Hello everyone. Today I am going to tell about intersection of sets, properties, disjoint sets, and solutions of question 5 to 8 from exercise 1.4 from Ncert class 11. If you take any two sets and if you write the common elements of those two sets in a set, then that is called intersection of those two sets. So here the intersection of sets A and B is the set of all elements which are common to both A and B. So it is denoted by this symbol, and this you can write A intersection B like this. For example, here A is equal to 2, 4, 6, 8. These are the elements of A set, and 6, 8, 10, 12 are the elements of B set. And if you see here, the common elements of these two sets are 6 and 8. So here A intersection B is equal to 6, 8. These are the elements of A intersection B. And the second example, AE, IOU and AIU. These are two sets, and here AIU are the common elements of these two sets. So here A intersection B is equal to AIU, that is equal to B. If you see here B is a subset of A because all the elements of B are also elements of A. So B is subset of A, then A intersection B is equal to B. And if you write intersection A intersection B in a set builder form, you can write like this: A intersection B is equal to X such that X belongs to A and X belongs to B. In union case, A union B is equal to X belongs to A or X belongs to B. But here in intersection, you have to write X belongs to A and X belongs to B. Now you can represent A intersection B by Venn diagram like this. For example, if you take A is equal to 1, 2, B is equal to 2, 3, 4. So here only 2 is the common element of these two sets. So A intersection B is equal to 2, only one element. So this you can show by Venn diagram like this. You know that this is a universal set, and here this is A set. In A set, 1, 2 are the elements, and B set 2, 3, 4 are the elements, and 2 is the only common element. So this shows A intersection B. This is the common area. This is the This is A intersection B. Only one element, that is 2. Now I am going to tell some properties of intersection of sets. The first one is commutative law. If you take any two sets A and B here, and the common elements of these two sets is only one element, that is 2. Therefore, A intersection B is equal to 2. And if you intersect B and A, then B intersection A is also 2. Only one common element. Therefore, A intersection B is equal to B intersection A. The intersection is commutative. If you write, while doing the intersection of any two sets, if you write the sets in any order, then you will get the result same. And next one is associative law. If you take any three sets, if you intersect the first two sets, A intersection B is equal to here 2, and A intersection B, intersection C. If you intersect with the third set, then you will get this 2. See here A intersection B, that is 2, and C 2, 3, 4 are the elements. So A intersection B intersection C is only one common element 2. Therefore that is 2. And if you intersect B and C, B intersection C is equal to 2, 3 are the common elements. So 2, 3, and A intersection B intersection C. So you have to check these two, 1, 2 and 2, 3. 2 is the only common element. So 2. Therefore, A intersection B intersection C is equal to A intersection B intersection C. So, if you intersect any three sets, if you can write in any order while intersecting any three sets. So, the intersection is associative. Next one is identity element of intersection. If you take any set, A is equal to 1, 2, and universal set is always contains the related set elements. So here universal set contains 1, 2 also. So 1, 2, 3, 4. These are the elements of universal set. If you intersect universal set with any set, A intersection U is equal to the common elements are 1, 2 here. So that is nothing but the set itself, the elements of the set itself. Therefore, A intersection U is equal to A. Therefore, intersection of any set with universal set will be the same set. In union case, the identity element of union is an empty set. Here, it is universal set. And next one is idempotent law. If you take any set A is equal to 1, 2, if you intersect the set with the same set, you will get the same set. Therefore, intersection of any set with itself revert the same set. Next one is the law of empty set. If you take any set, if you intersect that set with an empty set, you will get the empty set itself, because you don't get any common elements here. So you will get the empty set itself. Therefore, intersection of any set with empty set will be the empty set. This is law of an empty set. Next one is distributive law. Intersection distributes over union. If you take any three sets, A, B, C like this, and B union C. So if you union these two sets, B and C, write all the elements of these two sets. So 1, 2, 3, 4. Here, without repeating any element, you have to write here B union C and A intersection B union C. So you have to intersect A and B union C. The common elements are 1 and 2. So write here 1, 2. And if you intersect AB sets, A, B, common elements are 1, 2. So write here, and A and C, intersect A and C. The common element is only one element 2. So write here. And if you union these two sets, A intersection B and A intersection C, then 1, 2. So the elements are 1, 2. Therefore, A intersection B union C is equal to A intersection B union A intersection C. So this is distributive law. Similarly, you can write A union B intersection C is equal to A union B intersecting A union C. So here A intersection B union C is equal to A intersection B union A intersection C. And next one, disjoint sets. If you take any sets and if there are no common elements for those two sets, then those sets are called disjoint sets. So if you intersect those two sets, because there are no common elements, you will get no elements. So that is an empty set. Therefore, here if you see here, A is equal to 1, 2 and B is equal to 3, 4, 5. A intersection B is equal to, there are no common elements here. So this is an empty set. Therefore, if A intersection B is equal to an empty set, then AB sets are called disjoint sets. If A intersection B is not equal to an empty set, that means some common points or some common elements are there, then AB sets are called intersecting or overlapping sets. Now I am going to tell the solutions of question 5 to 8 from exercise 1.4 from Ncert class 11. This is fifth question. Find the intersection of each of the following pairs of sets. The first one is x is equal to 1, 3, 5 and y is equal to 1, 2, 3. So you have to intersect these two sets. So see the common elements here. Those are 1, 3. So x intersection y is equal to 1, 3. And next one is A is equal to AEIOU and B is equal to ABC. A intersection B is equal to only one element is common. So A. We know that if there is only one element, that is called singleton set. So here this is a singleton set. Next one, third one. A is equal to x is a natural number and multiple of 3. So we know that natural numbers are 1, 2, 3, etc. and multiples of 3 are 3, 6, 3 3s are 9 and 3 4s are 12. These are multiples of 3. So A set you can write in a roster form like this: 3, 6, 9, 12, etc. because x is a multiple of 3 as well as natural number. And B is equal to x is a natural number less than 6. So less than 6, the numbers are 1, 2, 3, 4, 5. And the intersection A intersection B is equal to, here only one element is common, that is 3. This is also singleton set. Next one is fourth one. X is a natural number and 1 less than x less than or equal to 6. So write here in a roster form 2, 4, 5, 6. These are the elements here. And in B set, 6 less than x less than 10. Between 6 and 10, the numbers are 7, 8, 9. So if you see the common elements, no common elements here are there here. So A intersection B is equal to an empty set, no elements. So it is an empty set. Here we know that we just learned A intersection B is equal to an empty set. Those sets are called disjoint sets. And fifth one, this is fifth one. A is equal to 1, 2, 3. B is an empty set. A intersection B is an empty set because if you intersect any set with an empty set, you will get an empty set. There are no common elements, so it is an empty set. This is law of an empty set. And next one, sixth question. You see here, there are 4 sets are given A, B, C, D, and you have to find all these values. A intersection B, B intersection C, like this. You have to find all these values. Here is the solution. You can see. First, write the sets here. And first one is A intersection B. So see here the common elements are 7, 9, 11 here. So right here B intersection C, next one. So common elements are here 13 and BC. Only 11 and 13. 11 and 13. So right here and A intersection C. So A and C only 11. 11 is the common element. So right here. And next A intersection C intersection D. Third one you have to find A intersection C intersection D. So first find A intersection C, then A intersection C intersection D is equal to, now intersect this set with D, 15, 17, here 11, 15, 17, there is no common element, any common element. So here it is an empty set. Next one A intersection C, A, C, only 11. And next one B intersection D, B, D, no common elements, so an empty set. And sixth one, you have to find A intersection B union C. So first to B union C, right? B union C, write all the elements of BC, 7, 9, 11, 13, 15. Then A intersecting B union C. So here A 3, 5, 7, 9, 11, 11 and B union C 7, 9, 11, 13, 15. Only 7, 9, 11 are common elements. So here the answer is 7, 9, 11. And next here seventh one, A intersection D, AD, no common elements, empty set. And B union D, write all the elements 7, 9, 11, 13, 15, 17. A intersection B union D, you have to find A intersection B union D. So first find B union D, then A intersection B union D. Here A, this is A set, so this is B union D. So common elements are here and here 7, 9, 11, 7, 9, 11. Next one you have to find A intersection B union C. So first find A intersection B. Here A intersection B, A, B, 7, 9, 11 and B union C, write all the elements here. And A intersection B union C. So you have to check these two sets. Common elements are 7, 9, 11. Next you have to find A union D intersection B union C. So first find A union D, then B union C, then find A union D and A union D intersection B union C. That is 7, 9, 11, 15. So you have to find like this. This is seventh question. If A is equal to X is a natural number, B is equal to X is an even natural number, C is equal to X is an odd natural number, D is equal to X is a prime number, you have to find all these values. So here all sets are given in a set builder form. You have to write in a roster form first. So first write here A is equal to X is a natural number. So natural numbers are 1, 2, 3, 4, 5, 6, etc. These are natural numbers. And B is an even natural number. So even natural numbers are 2 even numbers, 2, 4, 6, etc. And C is an odd natural number. So 1, 3, 5, 7, etc. These are not divisible by 2. Even natural numbers are divisible by 2. And D is a prime number. Prime numbers are the factors only 1 and the number itself. So those numbers are 2, 3, 5, 7, 11, 13, 17, etc. These are called prime numbers. So right here D set. And now you have to find these values. A intersection B. So see here A intersection B. Here 1, 2, 3, 4, 5, 6 and 2, 4, 6. Only if you take 2, 4, 6 all even numbers. Those are the common numbers for these two sets. Common elements. So you have to write 2, 4, 6, etc. These are nothing but B. B set. So here, if you write this set as a set builder form, you have to write like this: X such that X is an even natural number. So this is B set. You can directly write the same thing. X is an even natural number. This is B. And next one is A intersection C. A, C. So common elements are 1, 3, 5, 7. Same. So this is equal to C. So C is X is a odd natural number, an odd natural number. These are odd natural numbers. So right here, next A intersection D. So A and D. See here 1, 3, 3, 5, 7. Here 2, 3, 5, 7. So you have to write 2, 3, 5, 7. So that is equal to D. Same. A intersection D is D. That is equal to X is a prime number. X such that X is a prime number. And next one is B intersection C. So now see here B intersection C. These two. No common elements because these are even numbers, these are odd numbers. There are no common elements for these two sets. So this is an empty set. Law of an empty set. Next one is B intersection D. And B and D. See here only one common element 2. We know that 2 is an even prime number. Only 2 is the even prime number. So here 2 singleton set X such that X is an even prime number. And next one is C intersection D. So C intersection D. See here these two sets. C intersection D common elements are take out 1, 2 and only 3, 5, 7 etc. These are the common elements 3, 5, 7 all odd numbers. All odd numbers except 1. So C intersection D is equal to 3, 5, 7 etc. So these numbers are odd prime numbers X such that X is an odd prime number. These numbers are called odd prime numbers. Only prime numbers means 2, 3, 5, 7 etc. Only 2 is an even prime number and 3, 5, 7 etc. except 2, the other prime numbers are odd prime numbers. So right here X is an odd prime number. This is a problem. Which of the following pairs of sets are disjoint? We know that there are no common elements of any two sets, then those sets are called disjoint sets. So A intersection B is equal to an empty set, then those A, B are called disjoint sets. So we have to see here there are 3 sets are given, which are disjoint sets. You have to check. So the first one is 1, 2, 3, 4 and this is one set and X is a natural number and 4 less than or equal to X less than or equal to 6. This is another set. We have to check whether these two sets are disjoint sets or not. So first one, it is in a roster form. So write here 1, 2, 3, 4 and this is in a set builder form. You have to write in a roster form. So here X is a natural number and 4 less than or equal to X less than or equal to 6. So here X is from 4 to 6. So those numbers are 4, 5, 6. If you intersect these two sets, 1, 2, 3, 4 intersection, 4, 5, 6, here only 4 is the common element. So one element is there here. So these sets are not disjoint sets. Hence the pair of sets is not disjoint. And second one is here the first set AE, IOU and second set CD, EF. Yes, here E is common. So here also one common element is there. So this pair of sets is not disjoint. And third one, X is an even integer and X is an odd integer. This is another set. So we know that integers are positive, negative numbers including 0. So from that integers, you have to take out even integers. So even integers, we know that even numbers are, those are divisible by 2. So 2, 4, 6, all these numbers are even numbers, but even integers. So you have to take the negative numbers also. So minus 4, minus 2, minus 6, etc. 2, 4, 6 and 0 is also an even integer. So these are called even integers and X is an odd integer. The number which should not be divisible by 2. Those numbers are called odd numbers. But here integers, so you have to take negative numbers also. We know that odd numbers are 1, 3, 5, 7. All these are odd numbers. But integers, you have to take negative numbers. So you can take minus 5, minus 3, minus 7, 1, 3, 5, 7, 1, 3, 5, 7, etc. These are called odd integers. If you check these two sets, any common elements. Here there are no common elements. So this is an empty set. No elements are there. So this is an empty set. So if you intersect two sets, then there are no common elements, then those sets are called disjoint sets. So this pair of sets is disjoint. Now please do these practice questions. Here are the answers. The answer is not given. Is an empty set.